My name is Maury Vander. I'm the Chief of Test Operations. And once again, welcome to Stennis Space Center. Okay, so you're standing in front of the B stand. Was built in the 60s to test the first stage of Apollo. So that was done on the B2 side, which is the same side we're going to put Artemis on. So it had 5 F1 engines on it, total thrust of about 7.5 million pounds. So it performed admirably and did everything it was supposed to do in the 60s. It got retired, reactivated for what we call main propulsion test article, which was a shuttle, which was 3 shuttle engines firing there at the same time. Somewhere in the mid to late 80s, they decided they needed another test position for Space Shuttle main engine testing, so we activated the B1 side, which is the side on your left. So we tested Space Shuttle main engine there for about 10 years, converted it in the late 90s to RS-68, which is the project that's there now. So it's the propulsion system for the Delta IV, so it's the engine that's on Boeing's Delta IV vehicle. Actually, they're making final preps. They're supposed to test it tomorrow. So we'll have a hot fire test here tomorrow. But for us, the real excitement right now is what's going on the other side. We spent many years getting preparations done and everything ready for a Artemis core stage, which is supposed to show up here shortly. And when it does, it's gonna arrive from MAF, and you guys went to MAF yesterday, right? Most of you did. You guys saw Pegasus.
Yes.
We'll roll it on the Pegasus, route it through our canal, through the Gulf, into our canal system. If you came into the South Gate, you crossed the drawbridge. That's where the canal system starts. It's 7.5 miles from that point out to here, roughly. So it's going to show up and park right there. We'll roll it off. We will attach that spider, which is that vertical yellow piece of equipment that you guys found so fascinating a little while ago. We'll attach that to the head of the rocket. We'll attach the facility crane up top to that. We'll also attach the crane that you see right here to the tail end. We'll basically lift it up, roll it over. The bottom crane will drop off, and we'll use the other crane to go in. Those levels you see up there where the yellow handrails are, level 16 and level 19, those are removable, so they will come off, and they'll kind of slide right in there. Lower a little bit and attach it, and be ready for all the testing that comes with that. And with that, I'm going to turn that over to Mr. Nappi, who's our expert on our Artemis core stage, and I can get this thing off of it.
Morning. My name is Mark Nappi. I'm with the Boeing company, and I'm going to be the director of the green run test for the core stage once the vehicle gets here. I'm going to talk to you a little bit about what we're going to do when the vehicle gets in the stand and what leads up to the actual hot fire. So this is, first of all, a very coordinated effort with the NASA Stages Office out of Marshall. Lisa Bates is my counterpart for NASA, with the Stennis NASA group and the contractors at Stennis. With Boeing, we all work together to make this all happen. So how many of you have seen an Apollo or a shuttle launch? All right, imagine that event with the vehicle bolted down. That's what we're doing here. We're gonna flight test this thing for 8 minutes, over 8 minutes, with the vehicle bolted down. All right, in order to get ready for that, we've got a lot of work to do. Okay, we have to put the vehicle in the stand. Once we get the vehicle in the stand, we're going to do something right up front that's called a modal test. And we're going to pick the vehicle out of the stand, and we're going to just basically hit it with that big hammer and get a vibration out of it and make sure that it behaves like our models say it behaves. Okay, then we're going to do that 3 times, put it back down in the stand, and then we'll be ready to start getting into the vehicle so that we can start testing. Okay, so we'll take a couple of weeks. We'll put access in the vehicle. We need to get access into the engine section. We need to get access into the inner tank, and we need to get access to the forward skirt. And we need to get access in there so that we can start configuring the vehicle for test. This is going to be the first time that the vehicle is going to be put into this stand, and it's going to be tested with software that it has never seen before. So we have to run through a series of tests to make sure that the software, the vehicle, and the stand all work together properly. So when we do get into hazardous tests like the hot fire, it's all working like planned. So those tests are going to take a couple of months. It's very slow and methodical to make sure that every indication that we get back is what we expect, and every command that we there's also some work that we have to complete inside the vehicle in order to get ready for the hot fire test. Some of you may have caught yesterday that the LH2 feed lines that come out of the bottom of the tank are come up from the engines and hooked to the bottom of the tank. Those aren't connected yet. It's going to take us a couple of weeks or a couple of months to get those connected so that we can get into the main propulsion test. Okay, so it's going to take us about 4 or 5 months to get ready and to be to a point where we can actually do a wet dress rehearsal. And the wet dress rehearsal means that we're taking LOX, liquid oxygen, liquid hydrogen, and we're filling the vehicle and we're making sure that the propulsion system doesn't leak. Okay? It'll prove that we can load the vehicle safely, and it'll also prove that we can detank the vehicle safely. Once that's complete, we'll turn the vehicle around, we'll get more commodity, Stennis will bring in more LOX and more LH2, and about a week later, week to 10 days later, we'll actually run the hot fire test. The hot fire test is a full 8 minutes, over 8 minutes of firing the vehicle while we check all the indications and we make sure that the propulsion system works properly. After that test, then we're ready to start refurbishing the vehicle so that we can put it back on the barge and send it down to Florida. That'll take a couple of months. The main driver there is to get the engines in a position where they've been refurbished and safe enough to put on the barge, and we'll do some repairs. That we're sure to see some TPS or some thermal protection damage, that type of thing. We'll do some repairs, and what we can't get done here, we'll take to Florida and we'll finish it in Florida. So the whole test takes about 10 months. Okay, so we get here at the beginning of the year and we'll be ready to ship sometime before the end of October. Okay? So that's kind of a simplified version of everything that we're going to do here. And if you guys have any questions, I'm sure Maury and I can answer them, or try to answer them. It's actually bolted to the same areas that the SRBs are bolted to when we put the vehicle together. So we have SRB attach points at the engine section, and we have SRB attach points at the inner tank.
Solid rocket boosters.
Right.
So how much fuel will the engine burn?
It's on that level.
You want to talk about the amount of fuel that you're going to provide?
Sure. Now, you guys can see we've got some liquid oxygen barges here. We've got 2 of them there. We also have 2 liquid hydrogen barges there. Each of those barges is capable of holding roughly 100,000 gallons here, roughly 240,000 gallons there. We're going to have 3 of each on the day of test. Your vehicle holds about 550,000 gallons of liquid hydrogen and about 200,000 gallons of liquid oxygen or so. So it's going to pretty much take everything we've got to fill it, chill the facility, chill it in, and make everything happen. But we've got some margin there. Maybe not as much as we'd love to have, but we've got enough that we have confidence that we can pull it off. During the actual 8-minute run, it's going to be, we're going to deplete most of that. Roughly probably 500,000 gallons of hydrogen and somewhere about 170,000 gallons of liquid oxygen. So we're going to go through quite a bit. Now on the wet dress day, we're going to detank it. We're going to capture the hydrogen back, but we're going to actually dump the liquid oxygen. So we're going to take that and dump it to our dump pond, which is on the backside, and get some additional commodities in, as Mark described, to be able to make that 7-day, 10-day turnaround that we talked about. Yes, sir.
Is there significance to the 8-minute runtime?
It's a full flight firing. So we're just going to simulate the flight. We've also looked at what happens if we go a little shorter than that, and we have some acceptable times that we believe will satisfy enough of the test objectives to be fine. But the safest way to drain the tank is to run it through the engines.
Fastest way for sure.
Yep. The Irish people love it that way. It's about an hour and a half of our life to get back.
Can y'all talk about the corrosion that happens when at the plane trench, where at the business end of the rocket? Over the years, I guess from the Apollo, has it had to be replaced?
It's not been replaced. There's been some activities to refurbish it, but as far as replacement,
changes you have to make? What kind of preparations?
Just depends. For example, like a day like today, we wouldn't even try to put the vehicle in. We've got strict wind restrictions that say we won't lift it off the cradle without. So that wouldn't happen. We are subject to rain, but rain doesn't necessarily stop us. In some cases, lightning will. Most cases, lightning will.
You had any damage over the years with hurricanes and such?
Well, we've had some, not major. Look at that structure. It takes a lot to damage it. Some of the supporting infrastructure we've had some small issues with. For the most part, it's kind of like it was in the 60s. It's held up very well.
A good portion of our work is protected. We're inside the vehicle or inside the stand. For the stuff that we're not protected, we've made some accommodations in our schedule to deal with bad weather. We have lightning, we have high winds. We've already got some time there that says that's going to happen and we're okay. We've got it on our schedule.
But you're going to have that vehicle in the stand for a number of months.
10 months. Yeah. Any other questions?
What happens if it fails? The test.
So right now we have one hot fire planned and one wet dress. So if we wet dress and we have a leak, well, we're going to have to isolate the leak and figure it out and fix it. If we attempt a hot fire and we have a piece of hardware, a black box that fails, we'll stop the test, we'll change the box out, and we'll try it again. So it's very similar to a launch attempt. You have a problem, you find out what it is, you fix it, and you try again. All right, you want to take them around?
So yeah, I guess we can take them around.